This video aims to show you how to do a one-way repeated measures ANOVA. Here we have some data taken from a study looking at the effect of exercise on salivary cortisol. So you can see here you have the participant numbers. We go into variable view. This is how that's set up, as previous videos have shown. So you've got the variables of salivary cortisol pre and post exercise. So if we go back to data view, you can see that this is the salivary cortisol pre, and this is one participant with all the participants, and then 0, 15, 30 and 60 minutes post exercise. So the one-way ANOVA is looking to see if there's any differences between any of these salivary cortisol variables. So to run the ANOVA, you go to Analyze, General Linear Model and Repeated Measures. But once you click on that, you get a box open up, and you need to type in the factor that you're going to be measuring. So for this we're going to put in time, because we're looking at the differences in salivary cortisol over the time periods, and as you can see there's 5 time periods, so we add that variable in. Next you click Define, and this box opens up. So in here, this is the 5 time variables, and all you need to do is transfer them over into there. For speed you can just press Shift and then select all and then put them over. So these are the 5 time variables. There's just a couple of other things you need to click to get on your output. So if you go to options, you can display means. So we want to see the means for the different time intervals, and also we want to look at the differences after the test is run between individual times. So you click compare main effects, and you're going to run a Bonferroni test, which is looking at multiple comparisons of means. You can also display the descriptive statistics, so have mean and standard deviation, and click continue. The other thing you might want to choose is plots, so we can look at the plots of time. So we'll just put time on the horizontal axis and add to that, and you'll get a graph which will show you the differences. Click continue. So once you've done that, that's everything you need to do. So when you're happy, you click OK, and you'll get the output. So this is the output you'll get. Obviously it depends what variables you've got. Your names will come here, so 1 to 5, and the next box should show you the descriptive statistics which we asked for. So you've got the mean values here for all the cortisol times and standard deviation, and there were 9 participants. You don't need to worry too much about multivariate tests. The Mortley's test of sphericity is interesting. Basically, this is looking if you go back up to the standard deviations, this test is looking to see if the standard deviations are even between all the time points, and if they are, then this sphericity will be assumed. So the outcome of this test is important to which box you look at further down. So basically, if this is significant, it means that the standard deviations are not, or variations are not even, so you cannot assume that the data is spherical. So if it's significant, the p-value is below 0.05, when you go down here you want to choose the second box, so the greenhouse geyser box, when you look at your test value. So you haven't got spherical data because all the variations are slightly different, so you go to the second box here. If this one was not significant, then you can choose the first assumption box. But on this occasion we're going to go down to the second box. So this is now looking at the differences between the values of salivary cortisol, and you can see here the value here is significant. So there is a significant difference at some point between these values. If we just go down to the bottom, you can see the plot. So this is pre, and then you've got the post values. So we're going to have a look in a minute to see which of these is significant, which difference is significant. So that's where your pairwise comparisons come in, and this is where you click your Bonferroni correction. So here you can see it's the statistical program has worked out the differences between time points and whether they're significant. So this is the mean difference, and then the value you're looking at here is the significance value. So here you can see between pre-exercise and post, time 1 and 2, there was a significant difference. So the p-value was less than 0.05. So between pre and post exercise there was an increase in salivary cortisol. However, when you look down, you can see that none of the other values were significant. So pre and 15 minutes post, pre and 30 minutes post, pre and 60 minutes post, there's no difference. If you scroll down, there were no other values of significance. There is a point to know that if the p-value is below 0.1, you can report it as a trend. So you may be able to consider that, especially if you've only got a small number of participants. So some of these values, there's a trend towards an increase because the p-value is below 0.1. So that could be reported in your projects. Think about that when you're considering your data. So there are some trends here for significance across different points. So look at the plot and consider where they are. So these could be reported as a trend. So once you've got this data, then you could obviously report these values in your projects. And this is basically just how to do a one-way repeated measures ANOVA.